Hello everyone, welcome to the course on hydrocarbons. In that we are discussing about alkynes. We have already studied about the structure of ethane and how to prepare the alkynes. Now we will learn about the properties of alkynes. So first let's see what are the physical properties of alkynes. The first three members are gases, the next eight are liquids, and the higher ones are solids. So here the first three members, due to the low molecular weight, they are present in gaseous form, and the next eight are present in liquid form due to increase in their molecular weight. And again the higher alkynes are present in solids due to the increase in molecular weight. And all alkynes are colorless, and ethane has a characteristic odor. Other members are odorless. Means ethane is having characteristic odor or smell, but the other members are odorless. They are lighter than water and immiscible with water. So they are not soluble in water because they are non-polar, and they are soluble in organic solvents like ethers, carbon tetrachloride and benzene. The melting point, boiling point and density increase with increase in molar mass. So these are some physical properties of alkynes. Now let's study about the chemical properties. Alkynes are usually show acidic character that can be determined when the ethane will react with sodium metal and sodamide. Since sodium metal and sodamide both are strong bases, it will react with those compounds to form sodium acetaldehyde with the liberation of dihydrogen gas. And why that alkynes will show acidic character? It is because due to the maximum percentage of S character. So in case of alkynes, the carbon is sp hybridized. For that reason, the 50% of S character and 50% of P character will be present. Compared to alkanes and alkenes, it has more S character, and therefore the sp hybrid orbitals of carbon atoms in ethane molecules have highest electronegativity, and hence they can attract or accept the shared electron pairs, and such kind of species are said to be Lewis acids, and thus alkynes will show acidic character. And alkynes will follow the following trend in the acidic behavior that can be observed here. Ethane is having greater acidic character than ethene, and ethene is having greater acidic character than ethane. And if all are alkynes only, then the one which is having low molecular weight will show high acidic character compared to high molecular weight compounds. So that's why ethane is having greater acidic character than propane, and propane is having greater acidic character than butane. So this is about the acidic characteristic of alkyne. And now we will see addition reactions. The addition in unsymmetrical alkynes takes place according to Markovnikov's rule. So how does this will takes place? Simply see here, I will consider one alkyne C triple bond C. When it is made to react with the compound HZ, in general it may be halogen or any other atom, it will react to form C double bond C plus H along with the formation of Z minus, because the H plus has attacked to this carbon and forms the bond because it is a electrophile, and now it will form a carbocation which is known as vinylic carbocation, because the double bond, after double bond a single bond is there. If such kind of observations are made, then such type of compound is said to be vinylic compound, and the carbocation is said to be vinylic carbocation. And again this Z minus will attack to this C, and thus forming the compound CH double bond CZ. So this is how the addition reactions will take place according to Markovnikov's rule. So now let's see the example of addition of dihydrogen. So simply if I consider the alkyne, okay, so here I have taken ethyne molecule. Now upon hydrogenation, the addition of hydrogen in presence of a catalyst is said to be hydrogenation. So first it will get converted into alkene CH2 CH2. Later again if I further add the hydrogen in presence of a catalyst, then it will form ethane CH3 CH3. So this is how the addition of dihydrogen will take place in case of alkynes. Now how does the addition of halogens takes place? So here if I consider an propyne, okay, CH3 C triple bond CH. So when I will add the halogen atom or molecule, so here I have taken Br2 molecule. Now according to Markovnikov's rule, it is an unsymmetrical alkene. So therefore what happens? CH3 C Br double bond CH Br. The addition of bromine will takes place at adjacent carbon atoms. It is said to be vicinal dihalide. Vicinal dihalide will be formed. And again if I add further Br2 to this compound, then what I will get? CH3 C Br bond Br single bond CH Br. So again this kind of compound will be formed upon addition of halogens. Here another Br will comes. Okay, so this is how the addition of halogens will takes place. And as you know, the reddish orange color of the solution of bromine in carbon tetrachloride is decolorized, and this is used as test for unsaturation. Means if any compound consists of double or triple bond, that can be determined by bromine test. So decolorization of orange, reddish orange color in carbon tetrachloride is the test for unsaturation. Okay, next we will see addition of hydrogen halides. The two molecules of hydrogen halides, it may be HCl, HB or HI, add to alkynes to form gem halides. And that can be understood by taking the example of CH triple bond CH. When the HBr is added, it will give CH2 double bond CHPr. So now again what happens? CH3 CHBr2 will be formed another mole of Br. So thus again if we add HBr, then you will get CH3 CHBr, and that is according to the Markovnikov rule. So this is about addition of hydrogen halides. Next, addition of water. What happens if we add water to the alkyne? Alkynes are immiscible and do not react with water. However, one molecule of water adds to alkynes on warming with mercuric sulfate and dilute sulfuric acid at 333 Kelvin for carbonyl compounds. So that can be given as CH triple bond CH plus HOH, that is water, H2O, in presence of the mercuric sulfate and this dilute sulfuric acid, it will form CH2 double bond CHOH, and again it will rearranges and forms isomer and leads to the CH3 C double bond OH. The formation of an aldehyde takes place and it is ethanol. So upon addition of water, the aldehydes or carbonyl compounds will be formed. It may be aldehyde or in some cases the ketone will also form. So this is about the addition of water. Next, polymerization. The linear polymerization of ethane takes place to produce polyacetylene. So as you know, polymerization means joining or linking the single units to form large molecule having high molecular weight, and that process is said to be polymerization. And upon polymerization of ethane, polyacetylene will be formed, and it is used for many purposes. The thin film of polyacetylene can be used as electrodes in batteries, and these films are good conductors, lighter and cheaper than metal conductors. And next one is cyclic polymerization. So ethane, on passing through red hot iron tube at 873 Kelvin, undergoes cyclic polymerization, and three molecules polymerize to form benzene. So simply let us consider the three molecules of ethane that can be represented like this. So when the three molecules of ethane undergo polymerization, so here what happens is these pi bonds gets shared between these two carbon atoms and hence forming the benzene. The benzene will be obtained due to the cyclic polymerization. Okay, so here simply the delocalization of pi electrons takes place when it is passed through red hot iron tube at 873 Kelvin. So this is known as cyclic polymerization, and one of the way to prepare the aromatic compounds by using aliphatic compounds.